Hello again. This video presentation is on Santilli's telescope, astronomical anomalies. So what we have is there are two types of light: ordinary light, which we are familiar with, and a second type of light called isodual light. Isodual light bends in the opposite way to ordinary light and has different properties to ordinary light. Normal astronomical observations have been set up the way Galileo's telescope was set up to deal with ordinary light. Santilli's telescope is set up to work with isodual light. There are objects in the sky that emit only isodual light and so are invisible to telescopes that have been set up to deal with only ordinary light. Comparisons are then made between astronomical observation made with a Galileo telescope with a Santilli telescope. The consequences, of course, are that much which is said in mainstream physics is wrong. So I'll be going into more details about that if any of that didn't make sense. This is a picture of Santilli and his telescope. Ruggero Santilli studied physics at the University of Naples and earned his PhD in physics from the University of Turin, and basically he has ideas which are deemed heresy to much of the mainstream. This is a good short video going into a bit more details about what's going on with the telescope. So claims are made being able to detect antimatter entities with this Santilli telescope in the night sky. This is an ordinary telescope, Galileo telescope. It focuses ordinary light which we are used to, and it uses a convex lens to focus it, and it does not focus isodual light. Isodual light diverges for convex lenses. Ordinary light follows a certain geometry, and isodual means follows a different geometry, and I give the definition there of isodual, which you can look up from Thesaurus. While Santilli telescope focuses isodual light, it's done with a concave lens. A concave lens does not focus ordinary light, so the geometry is convex lens converges ordinary light, concave lens diverges ordinary light, while we have a different geometry of a convex lens diverges isodual light, and the concave lens converges isodual light. People also ask, is congruent meaning equal? The word congruent means exactly equal in terms of shape and size. Even when we turn, flip or rotate the shapes, they remain equal. So the two types of light are congruent because you can flip one to the other. Everything seems to be set up for instruments, equipment, etc. to deal with ordinary light. So there are technical problems with dealing with isodual light, but basically that is what it is. Convex lens to focus ordinary light, concave lens to focus isodual light. If a light emitting source is purely isodual light, then it's invisible, undetected by an ordinary Galileo telescope. So when comparisons of images from a Galileo telescope with a Santilli telescope, they are not the same thing. What we have in the night sky is alien ET megastructures that are invisible to ordinary Galileo telescopes. So how come this has been missed? Well, we got our understanding of antimatter wrong. So the idea of antimatter goes back basically to this person. It's Paul Dirac. He was an English mathematical and theoretical physicist who is considered to be one of the founders of quantum mechanics. Dirac laid the foundations of both quantum electrodynamics and quantum field theory. So basically, the revolution in physics was quantum physics and Einstein's relativity, and this was back in roughly the 1920s, and Paul Dirac extended that to further with what became quantum electrodynamics and quantum field theory. And he came up with these things like antimatter. So what he did is he picked up things from this equation from Einstein. When P, which is momentum, is 0, we have the equation E equals mc squared. And that's famously attributed to Einstein, but if you look in the history, there's other people who were saying similar things. Anyway, E is the energy, m is the mass, and c is the speed of light, which has been deemed constant, and that constant is arguable. When P does not equal 0, the equation is a bit longer. It's written out like this. It's E squared is equal to, open brackets, mc squared, close brackets, and that's squared, plus open bracket, pc, close bracket, squared. And the thing to note is have E squared. And so you have this energy squared is E squared. If you take the square root of this, then most people would say the answer is E. But that is only the positive solution. Actually have a negative solution as well. So you have the square root as being a positive plus E and a negative minus E. So positive E times a positive E equals E squared, whereas a negative C times a negative C is equal to E squared as well. So you have positive and negative energy from the energy equation of shown earlier. And by convention, physicists usually take the positive solution and ignore the negative solution, so they only deal with positive E. They only deal with positive energy from that equation. Thus, when thinking in terms of matter particle and antimatter particle, such as the electron and anti-electron, the electron has a negative charge, and the antimatter particle equivalent to the anti-electron has a positive charge. And they've been thinking in terms of both having positive energy, which is plus E. Really should have been thinking in terms of a particle with positive energy plus E and antiparticle with negative energy minus E. And thus have got matter and antimatter wrong, and thus got light wrong and talk in terms of photon and antiphoton. So this whole idea of matter and antimatter has been messed up, and when it comes to doing their experiments, they're thinking in terms of antimatter still being positive energy along with ordinary matter. And the problem then being they've messed up the use of words. So thus, to compensate for them having messed up their terms, they've messed up the way they talk about matter and antimatter, we have to talk instead in terms of ordinary light and isodual light. So light bends under gravity like this, putting aside other things like Ed Dowdy, who wants to talk about those things differently. while isodual light bends the other way. And it's similarly for things like lenses. You've got a convex lens, ordinary light is being bent towards the focal point, while isodual light is bent the other way. The focus of thinking by people has been to only concern themselves with the light that can be focused, the ordinary light, by convex lenses, and ignore the isodual light. Hence everything's set up to deal with ordinary light, and thus presented with technical difficulties with existing instruments that have been set up for ordinary light if trying to deal with isodual light. Now, I was taught this at an elementary level in physics. That's the red line, it's representing light. And forget this line for the moment, the one shown going upwards to the right. The red light is the light going from one medium to another medium, and is bent as it goes from one medium to the other. But there's also this light which bends the other way. We are told to ignore that, but that is the isodual light. So what we have is, when we've got the light source, it starts off as a mix of ordinary light and isodual light. When it hits the medium, ordinary light gets bent one way and isodual light gets bent the other way. Thus we've been making incomplete astronomical observations from the very beginning, when Galileo started making them. I'll be dealing with astronomy in this video, but the same sort of issue applies with the microscopic. That he messed up about dealing with observations using light. Thus we've been missing images like this. This is a triangle that arguably could be an alien stroke ET megastructure. This is an image taken using a concave lens. So here's some images. We're now comparing a concave lens against what you would observe with a convex lens. And so they're looking quite different, these images. And so more images that are looking quite different from what you get from using a convex lens compared to what you get with a concave lens. And there's some more images showing the same sort of differences you'd get. Looking closer at one particular image, you can see using convex lens and a concave lens, you're getting different looking structures going on. Conclusions. Basically got everything wrong in our understanding of light, gravity, etc. And so the mainstream, what they do is just keep sweeping certain things under their carpet. They have what is called confirmation bias, the tendency to search for and interpret and favour and record information in a way that confirms or support one's prior beliefs and exclude other information. So what they've been doing is they've got their bias towards ordinary light, and they've been ignoring isodual light. They don't even recognise that isodual light exists most of the time. So thank you, that's the end of this little video. Thank you.